Okay, this is Mr. Hendrickson again. We're moving on to the next lesson, which is about maximums and minimums. It's 9-6. We're still talking about quadratic functions. We're going to stick with standard form, which standard form is when you have y equals ax squared plus bx plus c. One of the important things to do, and I noticed on some of your assignments yesterday, you have to start by labeling what the a, b, and c are. You should start with that anyways, because that allows you to find the axis of symmetry. And that's going to be, again, fairly important when we get to finding the maximum or minimums. To tell if a function has a maximum or minimum is fairly simple. We just want to identify the a and see if it's positive or negative. If the a is positive, and it says it here, it opens upward and has a minimum value when a is greater than 0. It looks better down here where it says if a is positive, the parabola goes this way, which means it has a minimum. So if the first number is positive, it will have a minimum. If a is negative, the parabola goes upside down and there's a top to it, so it has a maximum. So those are pretty easy to identify whether it has a minimum or a maximum based on the a. A is positive, you get a minimum. A is negative, you get a maximum. The idea is we want to find out what that max or min is, and that's where we have to do the axis of symmetry. The other thing that we're going to talk about is the domain and range of the function. And again, the domain is easy because the domain on quadratics is always all real numbers. We talked about that before the break. The range, we have to find the max or min first to identify the range. So we'll get to that when we do the two examples. So there's a couple pictures here. Hopefully those are helpful. If a is positive, again, it's a regular parabola. If a is negative, it's upside down. So that's where we're going to start heading down to our examples. So for example 1, here's our function. Again, it's in standard form. To me, it's pretty important that we label what a equals. In this case, a is -2, b is -4, and c is 6. So there's our a, b, and c. Part A, again, it just says determine whether the function has a maximum or minimum. If a is negative, we can look up here. To me, it's a good thing to draw. If a is negative, I know my parabola goes this way. So I know I get a top of the function, so it's going to have a maximum. To find that maximum, because part B says state what the maximum or minimum value is, I need to find the y value, but I can't do that until I get my x value. So I'm going to find the axis of symmetry like we did yesterday. And it has the formula x equals minus b over 2a. So for this particular example, I already labeled what a, b, and c were. So I'm just going to fill in those numbers into this equation where I have the minus b. Since b is -4, a minus -4 is +4. And then it's 2 times the a value, which in this case is -2. So I get 4 divided by, and 2 times -2 is -4. 4 divided by -4 is -1. So I end up with x equals -1 for the x value. But the maximum and minimum is actually the y value. So I have to go back through. I'm really finding the vertex, but I'm finding the y value. So I take this x value that I just found and put it back into the function. You have to be a little bit careful here with the -2x squared because we have to do the exponent first. Some people yesterday were doing the multiplying first. So it's -2. I put in -1, and that's squared. So you have to do -1 squared first, then you multiply it by -2. The next part says I have a -4 times the x value, which is -1, and then there's the +6. So I have to make sure I do the exponent first, which means I do -1 squared, which is +1. So I get -2 times +1. The -4 times the -1, that gives me a +4, and I have the +6. So -2 times 1 is -2 plus 4 plus 6. And when I do all that out, you get 8. So the y value equals 8. That is the maximum value of this function. If you want to write it as a vertex, that's not a bad idea if we go to graph it, because we get the point -1, 8, and that's the vertex. That would be the top of the graph. All right. So you can follow the steps through to find the maximum value, which gives us the vertex. For the domain and range, the next part, the domain is always all real numbers for all quadratics. Oh, that came out a little funny. It's the double R thing. For the range, we want to look at the y values. Now, since this is a maximum, for my range, I'm going to label it as y. Now, it's either greater than or less than. It's in the directions up here, it shows it, but if I know that this is a maximum, it can't get any bigger than this number that we already have, so I'm going to say it's less than or equal to the value you just found up here. So y has to be less than or equal to 8. Because 8 was the maximum, that's the biggest. It's every number that's less than that. So y is less than or equal to the 8. And again, the domain is always all real numbers for parabolas, because you can go left and right as far as you want. So if I was trying to graph this, I know that my function would, at -1, 8, would be the top of it, and it would be a parabola going this way. And I don't need to be exact yet. We'll get into the points being a little bit more exact next week, or actually not next week, is vacation, the week after. All right, one more example we'll go through for example 2. This one has a fraction in it, so the division's a little bit trickier, but again, we can use calculators if you need to. First thing I want to do is identify my A, B, and C. A is a half, which for this it may work if you use a decimal, 0.5. B equals 4, and C equals -9. I'm going to draw a line to separate this problem. Again, since A is positive for this one, when it says determine if it has a maximum or minimum, if you look back up in the notes, when A is positive, you get a parabola that's shaped the normal U shape, and that has a bottom, so it's going to have a minimum. And I want to find that minimum value for part B, and I do that by starting with the axis of symmetry. And the axis is x equals -b over 2a. I fill in these values. My b was 4, so I have a -4. 2 times, now my a here was a half, so again, if you're using a calculator, it may be better to do 0.5. So I end up with -4. 2 times a half is just 1, so I get x equals -4. That's the x value. In order to make sure I find the maximum or minimum value, I need the y value. And I'm going to plug -4 into this function for all the spots that I have here. So it's 1/2 -4 squared plus 4 times -4 minus 9. So again, this you got to be a little careful. Don't multiply. You have to do the exponent first. So -4 squared, -4 times -4 is +16. So make sure you do that part first. 4 times -4 is -16 minus 9. So 1/2 of 16 is 8 minus 16 minus 9. So 8 minus 16 is -8 minus 9 is -17. And that's the y value. So that is, in this case, the minimum value of my function. If I want to write the vertex, because if you were graphing it, you'd want that point. The vertex would be the x value and the y value. Okay, and then the last part, again, is just to fill in for the domain and range. The domain is always, it's all real numbers. And my range are the y values, so I start with y. And again, I know -17 in this case is the minimum, so that's the bottom of it. So I need all the numbers that are bigger than or equal to -17. And we can do these as set notation, but for now I'm happy with you writing the domain and range like that. So again, the major pieces of this is to find out, do you get a maximum or minimum? That's based on the a value, so you have to make sure you find your a. To find that max or min, you do need to do like we did in yesterday's lesson. Find the axis of symmetry with that formula for x. Plug the x value into your y formula to find that. That gives me the maximum or minimum value. And then domain and range. Domain is always all reals. The range are the y values. And they're either greater than or less than, depending on if it was a maximum or minimum, whatever that y value was. The rest of the problems on this will be your assignment for tomorrow, or for today, depending on when you watch this. Good luck.